But before we do that, let's write down some more math facts we have totally nice to know and we could prove. And I'll say math facts. So we just had that if A is a subset of B, then A intersect B is a subset, or A intersect B equals A. We also have that if A is a subset of B, that implies that A union B equals what? We did an example of this before.
I have a question, Professor.
Yeah, what's up, Hoffer?
If A and B are both in U, but A and B don't intersect, then what happens in case of union?
Oh, that's fine. So good question. So in our picture, this would be U, not opera, this said U. This would be A, this would be B. Two just totally disjoint, we'll end up calling it, sets. And so the union is just all that. Just everything in A or B. So an example, yeah. So they don't have to connect. So example would be like 1, 2, 3, union, 100, 1,000, and then like 55 or something like that. This is just going to equal 1, 2, 3, 100, 55, 1,000, or doesn't matter. Yeah, it's just, you just literally combine them. That's all it means. Good. So in our case though, if A is a subset of B, A union B, we kind of drew that picture before. We'd have A here, and then we'd have B here. Well, the union of both of them, you're not going to get anything more than B, because B already contains everything. So A union B is just B, because everything in A is already in B, so you're not really gaining anything.
But if it's the diagram I talked about, then we have
yeah. So if it's diagram, then A union B certainly is not A or B. Totally true. So here, A union B is not A, and A union B is not B. I guess I see that. But the important thing is here, A is not a subset of B. So just saying in the case where A is a subset of B, this is true.
In that case, that would be an empty set, right?
Yeah. Well, the intersection would be in this case, the intersection would be an empty set. Yes.
Yeah.
Totally. Exactly. And we're going to do that in a second. We'll say that, yeah. So we have this fact. We also have the fact that if well, we can just say for any sets A and B, A intersect B for all sets A and B. Why did I write it like that? For all sets A and B, plus A and B, A intersect B is clearly a subset of B, and A intersect B is clearly a subset, or a subset of A, clearly a subset of B. The reason being A intersect B is just everything inside A and B. But in particular, if you're at A intersect B, you got to be inside A, right? So it's a subset of A. And everything at A intersect B, it's got to be inside B. It's a subset of B. Draw the Venn diagram. Think about the middle part of the Venn diagram is fully contained in both A and it's fully contained in B. We also have that A is a subset of A union B, and B is a subset, and B is a subset of A union B. Because once again, A union B is everything in A or B, like everything in both of them, right? And so, or sorry, not everything in both of them, but like both the sets combined. And so clearly it's going to contain A. It's also going to contain B. Any questions? So these, I'll circle them, are like 6 kind of really basic facts that you are allowed to know and use. You don't have to prove. The proof but the proof of these would go just like we did prove this one. So it'd be just like this. But you know, a little different, of course. Any questions on this? Okay, today I feel bad. Today is like a really it's more like a what do they call it? It's more like a seminar or something like that. Where we're kind of like going over a bunch of different topics. We're not going too deep in any just yet, but we will later. But anyway, we only have 5 classes, so it can't be that much later. Coming up.